long chapter, so make sure you guys are paying attention at the start because we are going to build the baseline skills that will carry you throughout the rest of the chapter. So in 5.1, we're talking about exponents here, but particularly we are looking at multiplying monomials. Okay, remember a monomial is a singular term, and we're looking at exponents here. So the starter problem, how could you write each of the following differently? So let's start here with 4x, or 4 times x. So our 4 here, this is the coefficient of x. So remember, when we're multiplying things, it's like adding the thing over and over and over again. So 4 times x is the same as saying x plus x plus x plus x. Adding x 4 times. You're multiplying x. In the second example here, we have x to the 4th power. So our 4 here, this is our exponent on x. And remember, exponents designate that we're multiplying the base by itself that many times. So this is the same as saying x times x times x times x, multiplying x by itself 4 times. So in our own words, explain what the difference between a coefficient of a variable and an exponent. Okay, what does each tell you? So let's start with coefficient here. So remember, the coefficient tells me how many times the variable is being added. So how many times is being, or is added, I guess. Okay, addition is the big idea with our coefficient. With our exponent, it is similar, except we are talking about how many times we are multiplying the variable. So how many times the variable, which in this case, we can call the variable the base as well. My handwriting today. Is multiplied. Okay? The big idea with exponents is multiplication. All right. So down to the next section here, we are looking at expanded forms. So I'm only going to do numbers 1 and 3 as of now. We can do the others together in class. So remember, exponent tells us how many times the variable or base is being multiplied. So the expanded form for this one, we have a to the 5th power. That means that we are multiplying a 5 times. So that'd be a times a times a times a times a 5 times. And that is being multiplied to a 2 times. So times a times a. So if we were to count all of our variables, which is a, we have 7 total a's being multiplied by each other. So we can write this as a simplified form of a to the 7th power. A is being multiplied 7 times. Okay, we'll skip number 2 for now. Number 3, we have 4a squared to the 3rd power. So just like here, our base of our exponent here is 4a squared. instead of just a single variable, we do have a coefficient and an exponent. But don't overthink this one. This is the same as saying 4a squared times 4a squared times 4a squared being multiplied 3 total times. We can even expand this one more and expand our a squared inside our parentheses. This is the same as saying 4 times a times a, 4 times a times a, 4 times a times a. So we expanded our outside exponent. Now we expand our inside exponent. So from here, we need to count how many times each thing is being multiplied. So we have 4 times 4 times 4, which would be the same as saying 4 to the third power. 4 to the third power just gives us 64. And we have 2a's, 2a's, 2a's. That gives us a to the sixth power. A is being multiplied by itself 6 total times. All right. So next, we are going to look at rules for multiplying monomials. So the first rule that we look at is product of powers. So when we are multiplying two monomials with the same base, that is very important, it is the same as adding our two exponents. So this is the same as saying a to the m plus n power. Okay, in our example here, we have the same base, b in each. This would be the same as saying b to the fourth plus 7 power. 4 plus 7 power. 4 plus 7 is just 11. So in total, this is the same as saying b to the 11th power. Okay, power to a power. So when we are taking an exponent m and raising it to another power n, it's the same as multiplying our exponents. So this is the same as saying a to the m times n power. Okay, looking at our example, we have x to the third to the fourth power. So this is the same as saying x to the 3 times 4 power. 3 times 4 gives us 12. So this is like saying x to the 12th power. Okay, our third rule here is product to a power. So when we have a product here, we have a times b, or where you could either have a variable or a constant here for both of these. It's the same as saying a to the mth power times b to the mth power. So in our example here, we have 5 times b cubed to the second power. 5 would represent a, b would represent b, or b cubed would represent b, sorry. So this would be the same as saying 5 to the second power times b cubed to the second power. Okay, 5 to the second power, 5 squared just gives us 25. And you'll notice in our second example, we have power to a power. We have b cubed to the second power. So we're going to multiply our exponents. 3 times 2, that gives us b to the sixth power. Okay. The final example here is monomial to a power. So we have multiple terms here. A to the nth power, b to the nth power, all raised to the power of p. So you would you would multiply both of our exponents to the p power. It's kind of like power to power. So we have a to the m times p power, and b to the n times p power. Okay? In our example here, we have 3 terms. So we have 2 to the second power times our second term, x to the 4th to the second power, times our third term, y cubed to the second power. So we have 2 squared, which is 4, x to the 4th power raised to the second power. So we'll multiply our powers, power to power. So we have x to the 8th power. And then finally, we have y cubed raised to the second power. 2 times 3 gives us y to the 6th power. So monomial to a power is really like combining both product to a power and power to a power. All right. So taking a quick look at page 2, we are going to keep the examples section for class, but we can complete the top section first. So remember, an exponent affects what is immediately to its left. So in my first example here, I have 3 times 4 squared. The exponent is only going to affect my 4. So this would be the same as saying 3 times 4 squared, which is 16. 3 times 16 gives me 48. Okay, when we have something like this, we could either multiply inside our exponents and then raise it to the second, multiply inside our parentheses and then raise it to the second power. So this would be 3 times 4, which is 12 squared. 12 squared is 144. Or you can raise both of your terms to the second power. So you could do 3 squared times 4 squared, which would just be 9 times 16, which would also give you 144. In that case, it does not matter at all. Same goes with over here in the bottom left-hand corner. You could take both of these terms inside our exponent, or inside our parentheses, separately. So you could take negative 3 squared times 4 squared. Negative 3 times negative 3 gives us 9. 4 times 4 gives us 16. 9 times 16 still gives us 144. Or you could multiply these right away. Negative 3 times 4 gives us negative 12 squared. Remember, negative 12 times negative 12 still results in a positive 144. Okay, this is where things get a little bit tricky. Remember, you do need to follow PEMDAS, so we have to multiply our negative 1 outside at the very end. So you could break this up as negative 1 times 3 squared times 4 squared, which would equal negative 1 times 9 times 16, which would be negative 144. Or you could do this all at once. Negative 1 times 12 squared, which would also equal negative 144. So this top section here is just a quick review of how exponents work when working with constants. Okay, so in order to keep the video as short as possible, we are going to save the examples for class. Hopefully you guys have some sort of an idea of how to go about these questions already, but we will review the rest in class together. Thanks for watching.